right, last quiz of the year with our stats here. So, got a little multiple choice here to get warmed up at the start. Which measure of central tendency best represents a data set without outliers? That would be me. Because the key is without outliers. If you did have outliers, median's usually the best way to go. And unless there's some mention of modal values or values that repeat, mode wouldn't be a good idea, and variance isn't even one of the 3 measures of central tendency options. So that probably would not be a good selection. Just saying. All right, use the data set to answer the following questions. We're going to find the mean and the standard deviation. Now, I will mention a couple of things as we work through this one. Yes, I could find the mean just by doing it and dividing by 5, but the cool thing is if I do it in the list, I can get both of them at one time. So again, if I go to Stat, I'm going to edit my list. Now most of you will probably have a list in there. I do too at the start. So if you go back up all the way to the top of whatever list you are, list 1, list 2, list 4, whatever, and hit clear, again, remember it doesn't show it's clear yet until we come back down, then they're all gone.
How do you get there again? We go to Stat and then...
Stat, and that very first one, edit.
Okay.
And we're off and running. So I'm just going to go ahead and I'm going to type these values in. Now, this is a short enough list, I know. It would be awfully hard to screw this up. I can see all the values. But sometime if I had a longer list, by knowing that there's 5 pieces of data here, and I also can look and say, hey, there's 5, I can make this work. Okay, I know I did all the answers, or I got all my data pieces in. So once I have those all in my list, I'm going to go back to the Stat menu. So I'm going to hit Stat again, but this time I'm going to arrow over to Calc. Now again, this is where your little sheet from before could come in handy. You can use this Monday. You can use this Monday. Just to kind of give you a heads up, and I think I have copies of them back over in the folder still. So okay, back to our currently scheduled programming. So this one var stats, and again, whatever list you typed into, hit second in that number. So if it was just the first list, you hit second and 1. If it was 2, you'd hit second and 2. And you get here, and when it says find the mean, okay, the mean is the x with a line over it, which in this case is 14, so it's going to be D. Okay. Now the standard deviation, let me explain something on this. I didn't tweak this, and I noticed it when we started doing this morning. There's 2 actual ways to calculate standard deviation. There's one for a population and there's one for a sample. We didn't do sample because we're just doing some basic things to touch on, and I saw this morning I didn't change that on this. So for this point, but this will not happen on the quiz, we are going to tweak B to become 4.7. If we were doing it for the sample, it would be a much smaller value. So just something to keep track of, okay? But for our purposes, again, the standard deviation is going to be this one with the SX that you've got over here. Because what actually did happen on this one, if it was for the sample, that's what the standard deviation for it would be. So that's why the 4.2 was there to begin with. Just kind of an FYI on that, though. We're not going to get into sample versus population. Okay, classify the data in the table. Normally distributed, negatively skewed, positively skewed, cannot be determined. My suggestion would be to make yourself like a mini graph. Now, how specific you want to get with it is up to you. There's a couple of them in here, so I'm going to do it a couple different ways. Me, I kind of look at the percentages and go, okay, I think what I'm going to do is I'm going to do the percents up the side. I'm going to count by tens. That'll cover everything. And then down here, I've got less than 4. I'm going to call it, I know it's not 4 to 8, but it's close enough so I can actually fit the numbers in. 12 to 16, 16 plus. And you can, again, label them any way you want to. Because all I'm going to do is I'm going to make a histogram. I'm going to make a bar graph based on these percentages so I can get a little bit better of a picture of what this is going to look like. Because the whole idea of this histogram is so I can do that and get an idea of what any distribution is going to look like, whether it's skewed or not. This does not look normal to me. It doesn't look like a bell curve. So the question then becomes, which way is it skewed? Positively, because we look for the end where the little tail is at, where the skinnier part is, and that's heading off into positive values, so it's positively skewed. If it were heading off my little tail into the negative values, then it's negatively skewed. So again, a picture can be helpful when we're trying to do these. Okay. Car sales. The mean stay of a car on a lot being sold is 21 days, with a standard deviation of 3 days. The lengths of stay are normally distributed. What percent of cars are sold after having been on the lot for 18 to 24 days? So I take a peek. Here's the advantage of having this sheet. If I have a pencil, or I could just redraw one on my own, I can say, okay, the mean is 21. So that's the value in the middle. The standard deviation is 3 days, which means when I move either direction, I'm going to be adding 3 as I go to the right, and I'm going to be subtracting 3 as I go to the left. By doing that, then when it says what percent of the cars are sold after having been in the lot 18, 24 days, I just cover it up, and whatever percents are left, I add them up, I got the answer. So 34 and 34 is 68, which is letter A.
Why would you count the other 34? That doesn't even seem like it's like in that range.
Okay, let me pull this back up for a second.
Because it says 18 to 24, wouldn't it just
Yeah.
be the 134?
Between 18 and 24. So 18 starts right here. And then 224, so 24 would end. I'm just using those numbers that are down there.
What's the one in the middle?
21, because that's the mean.
Oh, okay, now I got you.
Yeah, the mean's always going to be in the middle.
Okay.
And then we just kind of break out from there in trying to figure out the values. So that's where the 68 is going to come from. So in the next one then, we've got a table of low temperatures in Honolulu. Find the standard deviation of the temperatures. We're actually going to get to it this time. And then it also talks about the central tendency. So again, my idea here would be to go back here, get myself a new list working. Now, if you didn't want to clear out the new one, if you just wanted to go to L2 and start, you could, but I like using the same one. And then I'm just going to type them in one at a time. And I'm going to make sure at the end that I have 12 of them, since we have 12 months that we're working with. And I look, and my last one's got a 12. There's 12 months. I feel good. So once I've done that, again, I'm going to go to Stat, but I'm going to go over to Calculate. And I am in list 1, so I'm going to do second and 1. And I get all my values. So what's the standard deviation? Right here, C, about 5.6. Now, which measure of central tendency is not a good representation of the data? Well, let's see. Let's start eliminating things. Which one of those 4 is not even a central tendency measure? Middle. There's no such thing as the middle measure of central tendency. So then I start looking, and I'm like, well, mean, median, and mode. Okay, maybe I should look at these values so I can figure this out. The mean is 59.3. My median, if I scroll down, is 58.5. What would the mode be for this one? Do I have any values that repeat? 66. Okay. So out of those options, Which one would you say, after looking at those temperatures, doesn't represent the data as a whole? Mode. Because that 66 is almost the highest temperature in the whole list. That's not true. An average or the median are kind of close together. So again, I may have to actually look at the numbers to figure that out, or maybe you're smart enough to just look at it and you know. But that's how that one would work. Flipperooski. All right. The diameters of pottery bowls are normally distributed. The mean of the diameters is 22 centimeters and the standard deviation is 2. What percent of the bowls have diameters between 18 and 26? Now let's say for some reason, I don't know why this would be because I have extras over there and you'll have your own, but you kind of forget yours. Now, if I was just going to make a quick sketch of mine, I'd be like, okay, the mean is 22. The standard deviation is 2. So when I go to the right, I add 2. When I go to the left, I subtract 2. And I would keep doing that. So I get to this point, I'm like, okay, there's my 18 and my 26. It's all that stuff in between. Now I'd still have to remember the percentages that go in the places. So it's 34 for each of those, and 13.5 for each of these, and then I just add them up. 47.5 is 95. But again, if you have the sheet, use the sheet. Keep it simple. But you just have to have a little idea on how that works. And then we're going to go back to the calculator again, it looks like. The table shows the heights of students in class 9. Find the mean, median, and mode. Okay. Not a problem. Stat, new list to play with. We'll clear the old one out. And we'll start putting these in one at a time. And all of a sudden it just disappeared. Okay, let's try that again. All right, let's do this again. Some of you are going to be ahead of me. All right. Oops. Be careful we actually get the right numbers in. Those last couple. Let's make sure I got this. It says there's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, feeling good. Back to stat. We want that one variable. Stats. Go. List 1. Okay, so my mean is 165. If I scroll down a little further, my median 165. So those two are eliminated. What's my mode? 175, because I've got 2 of them. That's the only one I have 2 of. Good to go. Could you do it all by hand? Sure, but I just like the calculator. All right, homework. In a survey of 320 students, 32% spent at least 1 hour per night on homework. Find the margin of sampling error. Remember, my margin of sampling error is plus or minus 1 over the square root of n. So, what I'm going to have to do is I need to find out what 1 divided by the, oops, not that. 1 divided by the square root of 320. Now, again, treat this like a standardized test. You're like, wait a minute, it should be 6% if we're rounding. I agree. But in this case, we go with the one that is closest when we know that we are right. But that is your formula that we're using for this. So I'd work that out and get my answer. Another table. Lots of tables, lots of data to play with. Table below shows the average employee salary in thousands at S&S Inc. for the last 5 years. Determine whether the data appears to be skewed or normally distributed. Now before, remember, we made ourselves a picture and I labeled everything. I'm not going to do that this time. This time I'm going to eyeball things in approximation to each other. I'm going to be like, okay, this is going to be my 27. So 24 would be slightly below that. 36 would be significantly bigger. 30 greater than 27, less than 36. And 26 basically is where that first one's at. Okay, I'm not getting style points for putting numbers in places. So I'm just going to do something that approximates it. So then I'd be like, okay, what do you think? Normally. I might get a slight, really slight skew one way or the other, but not so much that I'm not willing to say that it's pretty normal for the most part. So that's why the picture can help there. Okay. What percent of students have scored less than 45 points? Like I probably should read what's above here. The points obtained by students in a class test are normally distributed with a mean of 60 and a standard deviation of 5. Okay, so let's move this up a little more. So let's say we don't have a pencil and we don't want to screw up our sheet, so we're just going to look at it blank way here. So my mean is 60. My number in the middle is 60. And it goes 5 each time I go each direction. Where would I have to go to get to 45 points? Left, because I'm at 60 here, so it'd be 60, 55, 50, whew, 45. We're way over to here. So only 1/2 of 1% of students have a score less than 45. So you can do it without actually marking on there. You just kind of count them off and then use your hands or your fingers to figure out where it would be. Same thing with that next one. What percent of students scored between 60 and 65? If my mean starts at 60, this would be 65, 34. So I just kind of work that out. Again, nothing too terribly awful. Oh, wait. About what percent of students scored more than 75? Okay, I got to remember here. We started at 50 or 60. 60. Okay, that's kind of important to know. So 60, 65, 70, 75. 0.5 the other way. So whenever we're talking about these points or standard deviations, we have to pay attention to what direction we're going to. All right, last big chunk here. Use the data in the table that shows the per capita taxes in dollars in the 10 states listed to answer the following questions. Answer to the round to the nearest cent if necessary. Which measure of central tendency might a realtor in Maryland use to convince a client that per capita taxes were reasonable? Well, might it be good to know what the actual values of our measures of central tendency would be? Yes, yes it would. So we are going to take our list, we're going to clear this out one more time, and we're going to type these tax values in. So we can figure out the mean and the median and the mode and see which would be most sensible for us based on what we know. So we whack away here. All right, 10 numbers, 10 states. Okay. So I do my stat. And I get my list going. Okay, so let's see what we figure out here. I see the mean would be 1839.70. And if I scroll down a little bit, I see the median would be 1734, And then I stop and I look at all the numbers and I say, hey, none of them are the same. So there is no mode. So that's not even an option to consider here. So I got a 50-50 shot here. So let's reread the question again. Which measure of central tendency might a realtor in Maryland use to convince a client that per capita taxes were reasonable? We want to make it look like Maryland has cheap taxes. Now, if I use median, Maryland is above that in taxes. So I'd actually be looking like I'm spending more there, even though that's really the more accurate one. What I'd want to do here is I'd want to say, hey, notice all these states, the average, the mean's at 1839. You're only going to be paying 1790. So hey, move here, that's a good idea. So if I use the mean, I could say that my taxes in Maryland are less than the mean. Because if I use the median, the taxes are going to look more pricey, more expensive. Even though, to be perfectly honest, the median would be a better measure here because Delaware's kind of an outlier in all of this. So that would be more accurate, but again, you're a realtor. You're trying to sell some real estate, so you're not going to care about that. You're going to make the numbers say what you want them to say. Oh, find the standard deviation of taxes. We've done that. Let me go back up here. Standard deviation, $375.46. Now, let's come back to our person from Maryland here again. Even with the realtor, if the standard deviation is $375.46, using the mean or median, they're both going to be in that same area. Okay? Maryland, if I looked at the mean, is within one standard deviation. It's average. So you still should be able to get there. All right. The scores of written tests for a job is normally distributed with a mean of 50 marks and a standard deviation of 3 marks. About what percent of candidates scored more than 50 marks? And yes, it is simple as it seems. If the mean is 50, what percentage of people are over 50? 50. And it'd be the same answer if they said scored less than 50 marks. If you're asking from the median what percentage, it's either 50 or 50, more or less. And then the bonus, I'm even telling you the bonus question in advance. We're trying here. Survey of pet owners. 62% preferred dogs to any other kind of pet. The margin of sampling error was 5%. How many people were surveyed? Now remember, to find the margin of sampling error, one over the square root of n. But this time, they don't tell me the number of people. They don't tell me n. They tell me this part. So my job is to find n. They told me the margin. Now, can I just write 5 here? What do I have to put? 0.05. Because I have to have the 5% in its decimal form. You're like, well, what about the 62? Don't need it. And for our purposes, we'll leave the plus minus part where it's at. Ooh, so we have a little algebra problem here now. We need to solve for n. N's in the denominator of that fraction. How am I going to get it out of there? By what? I heard multiplying. Multiply both sides by whatever that denominator is I want to get taken care of. Because then over here, those go away, so it's not in the denominator anymore. We're getting there. Okay, so now n's not in the denominator anymore. That's good. Okay, so next I got to get the 0.05 off of there. So we're going to divide by 5/100ths. We're getting there, folks. We're almost there. square it. Because I got to get rid of the radical over here. And to get rid of the radical, we'll do the opposite, square it. And we find out 400 people got surveyed. So basically, again, you are looking at the quiz Monday. I'm just tweaking some numbers and a couple of tables a little bit. Same types of questions, same types of numbers of questions. So 1 divided by 0.05.
Okay.
So